This video we're going to talk about understanding ROC curves and precision recall curves. A question came up in our session about the ROC curve. So let me quickly go back to the slides where we briefly talked about ROC. So this goes back to supervised learning, a classification. So let me zoom in a little bit. So the ROC curves we briefly talked about here, but we didn't really get into details of it. So we said this is basically plotting the true positive rate versus the false positive rate. And you remember false positive rate is the same, the false positive is the same as the recall. Sorry, the true positive rate is the same as recall. So basically here we have recall, here we have the false positive rate. And the precision recall curve, it's basically the vertical axis in the ROC curves here is used as the horizontal axis, and on the vertical we have precision. So let's go back to the ROC curve. So we were saying it shows us what true positive we can get at what false positive rate. And just to remind you, a random classifier, so basically if you have a classifier that would randomly assign an input to either 0 or 1, you would basically have a line like this. And if you would have a perfect classifier, meaning it would be, it is able to perfectly identify the zeros and ones, then we would have a straight line up like this. But so what are these? So the curve is simply it calculates the true positive and false positive rate at a particular threshold. So we didn't talk about that threshold, what it is. So let me talk about the ROC curve in the context of the precision recall curve, the logistic regression. So remember in the logistic regression we were saying what it predicts is basically this probability. And usually the threshold is 0.5. So what it given an input, a logistic regression classifier predicts, say this input is the y is 0.15, but we're gonna assign it a 0 because it's less than 0.5. However, so let me show you another slide. Okay, so let's say these are the, let me zoom in. So let's say these are the predictions, the predicted probabilities, okay, what we have here. And if we would choose the default threshold, 0.5, all these, basically 1, 2, 3, 4, 5, 6, would be assigned a 1, and all these blue ones would be assigned to 0. So the prediction would be 1 for all of these, 0 for all of these. And this is 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so 8 out of 9, 10, 11, 12, 13, 14. So 8 out of 14 would be 0. 6 out of 14 would be 1. However, we could, instead of using the 0.5 threshold, we could use a 0.75 threshold. Basically, that would mean if the likelihood of belonging to the 1 class is greater than 0.75, assign it a 1, otherwise a 0. And so depending on where we set this threshold, so think of it as a horizontal line. Let me draw a horizontal line, and let's go with red. Okay. So depending on where we put this, the number of predicted true positives and as well as false, let me go back here, and false positive would be different, right? So if let's say we put it as 0.5, okay. So let's say these points actually all belong to the 1 class, okay, and these belong to the 0 class. And the model correctly predicts them all. So basically it says the probability is this, and I'm assigning it to the 1 class, and that's actually the true outcome. And these here actually are 0, and I'm correctly predicting, I'm basically predicting a probability of them belonging to the 1 class that's less than 0.5, so I'm assigning them to 0. So in such a case, we would have basically the true positives are all correct, right? So the true positive rate, the recall is basically perfect, is 100%, the true positive rate, yeah. And the false positive rate, let's go back. So false positive meant it predicts it to be positive, but it's false. It would be 0 if that's the case. But let's change it a little bit. So say the actual values of these three is a 0. But by using a 0.5 threshold, we would count them as positives, but they were actually negatives, right? But if we were to change this threshold, like say over here, say this is 0.8, we would be correctly assigning them to the negative class or to the 0 class. So that's the threshold that this that we're talking about here are basically the threshold for when to assign an observation based on its likelihood of belonging to the 1 class. Where do you want to set that threshold in order to decide whether this guy belongs to the 1 or to the 0 class? So we can play around with these. So for the logistic regression, I'm going to show you an example of this in a Python notebook. But let me go back here first. Okay. So this basically means if I decide at a particular threshold, let's say this dot here, I will have a false positive rate of 0.2 and a true positive rate of 0.5. And of course, what would be the theoretically perfect classifier? If you would have a false positive rate of 0 and a true positive rate of 1, basically this dot, that would be the theoretically perfect classifier because it labels all positives correctly, and 0, it has 0 false positives. That's the perfect model, basically, this dot over here. And so these curves are simply just connecting these dots. So we might have just a bunch of them, but we can connect them. It might not be a continuous line necessarily. Depends on how many thresholds we are trying. And similarly, so the precision recall curve, again, very similar thing. The only difference is now we are changing this threshold, and we are looking at the recall. We're calculating the recall and precision, say at this dot and at this dot. So at this point, at different thresholds, we want to see what trade-off we will have in terms of recall and precision. So let's take a look at an example over here. Let me reconnect. So I'm going to use the, let me zoom in a little bit and maximize this. So I'm gonna use this is too much. Okay. I'm gonna use the example, the second one that was posted on eLearn using a database, a social network ads. I'm gonna load that data set. So this is basically, we're gonna use gender, age, and estimated salary, or well, we're gonna do these two. And we wanna predict whether the customer clicked on a ad or not. Okay, and or let's ignore this. This is the other data set. It's over here. We can look at it later. I'm going over through two examples here. So y is the clicked is or y, the x is or is these two variables, and we're gonna go to the splitting. Let me show you over here. So the data prep 1 is the first data set I'm using, and I'm gonna post both of these on eLearn as well in case you want to further explore it. And now we split it. This is just to avoid showing us too many warnings. Same story, we do a 30-70 split, and we use the min-max scaler for the logistic regression. We initiate the logistic regression, we fit it on the transform data set, we do the predictions. So these are the 0 ones, okay? So we're gonna come back to this, and let's just make sure we have this, okay? This is the confusion matrix. Same thing, I just run all of them to be consistent with what you've seen before. and precision recall accuracy. Okay, and now we're creating these probabilities, and this is the ROC curve that we're looking at. And here I just drop those other so previously we were doing it like this. So let me show you what we basically what we were looking at before. So this was how your ROC curves were looking like. It had it for well, it was like this. It had both classes, the micro average, macro average, and I just want to look at the ROC curve for class 1, and that's why I did this line. Basically, I told it I don't want to see the macro and micro plots, and I am just interested here in class 1, whether or not somebody clicked on the ad. And so now these different points, they are just basically connected. And now let's see if we can retrieve the thresholds that it's being used to calculate these true positive, false positive rate. So we can do that with this ROC curve. So I'm going to use, instead of plot ROC, I'm using ROC underline curve, and I'm saying, okay, the y-test is the same. The predicted probabilities, what you're looking at here is when we use ypred prop. Let me do it here. So it basically produces the probability of the 0 class or the 1 class. But of course, they would always add up to 1, right? If you check a couple of them, you will see. So this is class 1, sorry, class 0, class 1. So it's always going to add up to 1. I just want to have, I just need these, basically probability of belonging to class 1. That's what I need to feed. That's what I need to provide as an input to that function here, ROC curve. So that's the only thing I'm doing here. I'm just saying take that second column, which is the probabilities for class 1, and I'm just telling it the positive label is a 1, and it's going to produce false positive rate. Basically, it retrieves all these places where you see we have these little dots, and I'm just putting everything in a data frame, nice and easy, so that we can take a look at it. And the first row, ignore it, that's arbitrary, but these are basically the values we see on this plot. So false positive rate of 0, we get a true positive rate of 0.02, that's this point. That's at the threshold of 0.89. So that means, ignore these dots, but let me just move this over. And let's see if we can zoom in a little bit. Okay. So that means if you set the threshold, this one, at 0.9, that's the true positive rate and false positive rate you will get. Okay. So looking at this, so we're talking about, so what would be a good choice? Again, it depends on what is more important. So remember we had, for example, a classifier for, if it's a classifier for detecting cancerous tumor versus it's a spam filter. So it depends on your application, which whether you would want a higher true positive rate at a cost of a higher false positive rate, or the other way around. And so this point seems like a good trade-off. So it's the true positive rate is above 0.8 something. Let's see. So we're getting around here. So it's somewhere, sum of, let me see, true positive is the second column. So we're talking about something here. And let's see, the false positive rate is merely 0.1. Okay. 0.118. So I would rather have a smaller false positive rate while having the same true positive rate. So here, these 2 points are the same. Let's see if we can find them. Okay, it's these two. So it could be the lower one, seems like. So this is the threshold here. So if it sets the threshold, if we use a threshold of 0.42, basically if we use something here, that's the true positive rate and false positive rates we will get. So that's what the ROC curve is showing us. And generally, if we want to compare models in terms of ROC curves, we will be looking at the area under it. So that area under the curve that we also talked about. Zoom in. So this one, we would look at the area under the curve for these two models. We don't have it right here. But it also shows you the value for it when you do the ROC curve plot using a sklearn. And you would then go with the model that has a higher one. Let's take a look at so hopefully this makes it more clear. And we have a similar thing for the precision recall. So let me just do it again. Just take the class 1. So similar syntax as above. So we're going to do this like what we did here. So I'm just going to copy these. It doesn't have a plot macro, so we won't need it. And run this. Okay, just for class 1. And again, so this is again showing us precision and recall at different thresholds. So let's see if we can derive these thresholds. So we're going to do a similar thing. We're going to have it calculate. So it's a similar syntax to what we have over here. So I'm going to just borrow from this line. And so we're going to do a similar thing. So this produces precision, recall, and thresholds. So it's going to create the values this returns, this function, precision recall curve. It gives us, similarly to what we had here, it produces 3 arrays. I'm going to do something like what we did in this cell, just to have a nice data frame. Otherwise, let me show you. If I run this and I just do say this, see, it doesn't look that pretty. So we are going to use what we had here, copied this, and just gonna rename this. This is precision, this is recall, and that's threshold. And we need to rename these so that it knows what it's referring to. Okay. And let's run this. Seems like we pulled the wrong entries. Yep, I forgot to name these. Yep, this should be a uppercase. What happened? Oops. Yep, this one. Missed something here. Let me fix this. Okay, so it turns out we can create that good, better looking data frame here. The reason is the outcome, the values this returns for the length of the precision and recall arrays is one longer than the threshold one, and that's because for that extra one that we had here, it would just add an arbitrary threshold, which is the maximum predicted probability plus one, but it doesn't do it for this one. So we can't just put them next to each other in a data frame, but we can still look at those values. So I'm going to do a separate cell, and so let me do precision, recall, and thresholds. So it's not as readable maybe as the previous one, but still we can figure it out. Okay, so and these are the values for precision for all those observations in X test, and at different thresholds, and these are the observations for um, recall. Sorry, let me correct that. Not the observation. These are the recalls at different thresholds, and these are the actual thresholds. So let's start with, say, from the end. The first value is showing us recall of 1, so it's this last point, and that is at a threshold of 0.89. So that means if we hold when it sets the threshold here at 0.89, this is what the precision and recall are going to be. So if we set threshold at 0.89, the recall is going to be 1, and I read this. Did I read this incorrectly? Yeah, no. Okay, the last one, we're going to ignore it and start from the one before it. Again, that's the last value is just is arbitrary in this case. And so it's going to be 1 and 0 0.20, 0.023. So 0. Let me forget the last piece I just said. I was looking at the first element of recall, so I should look at the first element of the threshold. So this basically means if I use the threshold of 0.32, basically if it sets it around here, then it's gonna this logistic regression classifier can give you a precision of 0.65, this point, and a recall of 1. If you want a higher precision, so let's see. Okay, so if we go forward, they're not always the highest. So let's say we want to go with something. Of course, the last values are all at 1. So these are all about here. So let's say we want the precision, like if we want to have perfect precision. These are going to be any of these values, so it would correspond to these recalls. And of course, if we can, let's say we want to go with the highest recall we can get while still getting a precision of 100%. So let's take a look here. 0.16 is the highest, seems like. Okay, so 0.16 it is. So I can get 16% recall if I insist on a precision of 100%. And for that, I need to choose a threshold of 0.85. So if I set the threshold to 0.85, I can get precision of 100% and recall of 16%. So I hope this makes it a little bit more clear how to basically what exactly precision recall curve or the ROC curves is telling us. So now a question came up, how about now so we can produce these also for, say, the decision tree, and let me do that. So I'm gonna use the same data set that we just used, train a decision tree, and do the same thing to the YPRED, look at the confusion matrix, and then do the plots. So you notice they look different here. Okay, so let's first change them and just look at class 1. So we're gonna do the same thing we did for these guys. We just want to look at, we want to clean up that plot just to look at. And here, I'm gonna do the same, but I'm gonna also add plot macro false. Okay, so I'm only looking at the class 1. So here, it's different because it seems like it's choosing only one threshold or maybe multiple. Let's see if we can pull the thresholds for this one. So I'm just going to do it for the ROC one. And so let's see. So the main point we want to get at is, okay, for the logistic regression, we're basically talking about where you move. This is the threshold that it's using to create the ROC curve. So what is it doing in the case of a decision tree, right? So here. So let's first see if we can pull those values. ROC curve. So we kind of do a similar, basically use the same line of code. And it's over here. So let me just use this. Copy this, and then we're going to y test and y pred prop are now these values. Okay, so let's see what do we get. Okay, so see, it's only, and again the first one is arbitrary, ignore it. So it only has calculated 2 points, so it's only evaluating it at 2 thresholds. And you notice it's a 1 and a 0. So choosing thresholds when it wants to plot the ROC curve for decision tree is going to be a little different. That's because let me try something here, and it would help me better demonstrate. Let's see if we can. So let me see if I can reduce the number of minimum samples. Min samples leave. Default is 1, so now it doesn't. So I wanted to allow it to further split if possible and see if it would create more thresholds. So let me get back and show you, tell you a little bit about how it would go about the thresholds in a decision tree. So we said the decision tree basically works by splitting the data so that the resulting subgroups are basically more homogeneous in terms of a metric such as the Gini impurity metric, or by reducing entropy, basically based on information gain. So let's say we're following this tree. At split 3 over here, so this is this branch, if we wouldn't go further down, how would it decide what color to assign to anything beneath this node? If it was x1 is less than 70, okay, it would be red. How about when it's greater than 70? We have a mix of green and red, and so here it would basically go by whichever has the majority, right? So out of these points we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 6 red ones. So this is basically gonna be assigned as green, and it considers. So if you compare it to that 0.50% threshold, it would make sense here. So basically, whoever has more is going to get assigned that color. So if I have more greens, I consider everything here. I consider the outcome here green if I wouldn't want to go deeper in this tree. So if I would limit the depth, say, to 2. But I could, theoretically, I could change that threshold and say, well, if I have at least 20% red, then I'm going to assign it, label that outcome as red. So if I would have done that, then I would get all red in this case. So that's how thresholds would work for a decision tree. And but you notice here, it only gives you, basically you have a threshold of 1 or you have a threshold of 0. That basically means you have to, if you follow up here, so either my options is I have false positive is 0, true positive of 0. Of course, you don't want that. Over here, you have true positive 1, false positive 1, and these are just the two ends. And let's see. Yeah, we can't really choose these as options. So basically, the only option, it's only calculating this for you at one threshold, at this 1. And this, if you compare it with what you had in a logistic regression, you see it's different. So it's not really, it doesn't really have many thresholds to work with, unless we would change things manually. And you usually don't do that in decision trees. If you would have, when defining the tree, specified that, okay, this is how I want you to decide how to go down the branches of the tree in terms of assigning observations to one of the outcome classes. We would need to override the default thing, so we're not going to get into it, but that's the idea. If you would have thresholds here, it would basically be how you decide to assign a label to points based on how many you see, percentage of the ones you see. So for the random forest, if you would run it, similar story. Let me quickly do that. So here you see you have a, you still have a, seems like you have multiple points, but let's use the same thing, just plot it for the one outcome class. And get rid of this one. Okay, so let's see what we are looking at. What are these thresholds? So I'm not gonna just say telling you now that we're not gonna get into details of this here, but you just want to explore it. Okay, so there are a bunch of different thresholds, and these are basically, so how many do we have? We have 10 basically. 1, 2, yeah. So for the random forest, remember how it was working was you have, say in this case, we have 10 trees. It would, for an input, see how many vote for each of the outcomes. So you have 6 vote 1, 4 vote 0, it's going to assign a value of 6. And the number of votes can be used in a similar way to how probability thresholds for a logistic regression are used. So this is how it identifies the thresholds, comes up with the thresholds of the ROC curve if you do it for a random forest. As I said, I'm not going to get into details of it, but if you want to think of it as the votes of the different trees in the random forest classifier are dealt with similar to the probabilities that we went over in the case of a logistic regression in order to do the ROC curves. And for the naive Bayes, so let's try that here, and let me run this. Similarly, let's just look at the outcome class 1 over here and over here. So for the naive Bayes classifier, what are we dealing with? So if you remember, I'm going to go back to the slides in a moment. Let me just also pull the thresholds as I did for this one. Okay, so we have a bunch of thresholds to work with, right? So how, where are these coming from? Well, if you remember from the naive Bayes classifier, what we were basically doing was we're going to come up with the probabilities for either of the two classes, and whichever has the higher one is going to be assigned So that new observation is going to be assigned to that class. And so here we have a very similar situation to what we had in the logistic regression. By default, the probability of 50% is used, but you could use different values, and these are what you're looking at here. So think of it as, where would you set the threshold of assigning non-observations to the one class? So let's take one for example, because here the interpretability is similar to what we did for logistic regression. And as a side note, if you look at this, you see the area on the curve is 0.95 naive Bayes, 91 for random forest, 88 for the decision tree, and 93, so naive Bayes would be our choice if we would go by these ROC curves and the area under the curve. So let's say we want to look at this point. It has a, let's say the true positive rate is very important for us. So we want to see what's the smallest false positive rate we can get while still having a true positive rate of 1. Okay, so I wanted to still have a true positive rate of 1. Of course, I don't want a higher false positive rate. I would rather have a smaller one if I can still get true positive rate of 1. So that's what I'm looking for, this point here. So see if I can figure out the threshold. So again, true positive is 1. We're going to look at, so all these are 1. So okay, seems like I need to, in order to have a true positive rate of 1, I have to at least be fine with the false positive rate of 25% or about 26%. And that's going to be at a threshold of 0.21. That means if I was doing the naive Bayes classifier, I would set it such that if the probability of belonging to the 0 class and the probability of belonging to the 0 class and probability of belonging to the 1 class are calculated, if this one is above or equal than 0.21, I would assign it to the 1 class. So that's what this means. But let's say we cannot allow false positives, so it's very costly for us to have false positives. Let's say we are, I can't think of this scenario, but let's say false positive rates are very costly, so we don't want them. We want to see we want to have something close to 0 if possible. So let's say we give it a little leeway, one of these values, that's about 1%, 1.3%. And of course, if I can get higher true positive rate at the same FBR, I'm going to do that. So I'm going to go with this. So I can get a false positive rate of only 1.3% if I'm fine having a true positive rate of about 40%. And that's going to happen if I set the threshold at 0.93. That means I'm only going to assign an observation to the positive class if it has a probability of belonging to this positive class of at least 93%, 0.93. So that's what it means here. So let's see, can we do the ROC curves for the k-nearest neighbor classifier? Yes, we can. Let's take a look. This doesn't look right. So yep, that cell was wrong. So let me change this to only look at the 1 class to make these plots less busy, similar to what we did for the previous ones. This one doesn't have plot macro. Okay, so similar story. So let's see whether it produces what we did here. We're gonna come back. That's I kind of want to show you something else here. Let me use this cell. Let's see if the KNN, what sort of threshold is looking at. Okay, so we have some sort of threshold. So how would it be possible to change this? So let's go back to the k nearest neighbor algorithm. You had it here. So remember how the k nearest neighbor works was it would so you specify the k. In this case, we've set it at 5, and we're using the Euclidean distance. And so now it's gonna basically assign the point to based on the counter numbers, whichever observations there are more. So if the observations in its neighborhood there are more zeros, it assigns the input to a 0. So in this case, the inputs are the test values, the x test. And if there are more ones in that neighborhood, it's going to assign it to ones. Again, here it's going to go by it's basically going by a something that we could compare to a probability threshold of 0.5 in the logistic regression. So basically, if I would have three purples and 3 yellows, what is k equals 6, let's assume, then it would be an exactly 50-50 chance of belonging to each class, right? But similar to what we did before, we could change those thresholds and say, okay, I want you to assign a point to purple if it has at least 20% purples in its neighborhood. So if I would have done this in this scenario, instead of that 50%, basically having a equal value for purples or yellows in my neighborhood, if I was saying, if you have at least 20% purples in your neighborhood, assign this point to purple, then in this scenario, this red new point would be assigned to purple. And that would be, let's assume purple is our 1 class, so that's something like this. If I would have set the threshold to 0.2, let's say it could have a true positive rate of 0.9 at a false positive rate of 0.52. So this is the only difference here is the thresholds that you're seeing over here. These are based on where do you want to set that choice between when a point is assigned to the 0 or the 1 class. So we could, let's pick, we have 1 and 2, 3, 4. Again, the first one is arbitrary, ignore it. 1, 2, 3, 4, 5, 6. These are the far ends of these 2 points. Let's say we would want to go with something in the, say here, we have I want a smaller false positive rate. 0.8, about 0.8 true positive rate, 0.3 false positive rate. It's this. So I would need to set my threshold at 0.4. Okay, and that was it. So now this was the story for the how the ROCs, basically the thresholds that are that we're talking about in the ROC curves are set for the KNN. And if you, so I won't, what we talked about won't be in the evaluation directly, but it's just to, I wanted to make sure you have a good explanation on what how these ROC curves are plotted and how to basically understand them. So one more thing, since we're talking about these thresholds, so I'm gonna go back to the logistic regression. I will quickly pause and take these up to the to where we're talking about the logistic regression, and then we're gonna talk about it. Okay, so we're back at the logistic regression that we did initially. So let me just do this again, just to make sure we have things right. and we're using the transform data set in this case, and we're looking at the confusion matrix, and then we calculated the probabilities instead of just the 0 1s. Okay, and let's run this again, and let's take a look at these probabilities. Okay, and well, let me do something. Let me just take the probabilities for the 1 class, and let's just look at these. Okay, so these are all the values. Okay, so this is, say, for X test. Let me show you quickly. Okay, so these are all the values that we have, about 120 of them. So these are 120 probability predictions. So it's basically predicting what's the probability of the first observation of belonging to class 1, second, and so on till the last one. So this is so now by default, so remember when we're saying by default this is set to 50%, right? So anything that is above 50 is assigned to a 1, anything below it is assigned to a 0. And so how would the precision and recall look like? It would be this, right? So I'm now going with the default. So we said when we are, so these ROC curve thresholds, basically these are values, this is showing us what the true positive and false positive rate would look like if I would go with different probability thresholds. So let's see how the precision, oh, I forgot to transform this, that's why this looks off. How the confusion matrix would look like, and this looks better. It should be the same as what we have here. So this is our confusion matrix if we would choose to use the default 50% or 0.5 threshold. So we saw here that it is, let me run this again. So it's calculating about 25 thresholds. So it's calculating that, so basically this plot is telling us how the TP and the FP look like at 25 different thresholds. So let's pick one of these thresholds and see how the confusion matrix would look like. And another reason we basically look at these curves is that I don't want to look at 25 confusion matrices or 25 precision recall values or TP FP values in a table. This way it's much easier to visualize what I want to pick or what I want to do. So let's see what the confusion matrix would look like if we went with this pick. So let's say again, having a kind of a balance between the true positive and false positive is what we want, but we would rather have a higher true positive rate. So let's go with this, and of course at about 0.80 something the true positive rate, I would rather go with a lower false positive rate if I can get it. So let's check what that was. So true positive about 83. We have 2 points there. Okay, 83 is one of these, and I'm gonna go with a lower false positive. So that's at the threshold of 0.43, about 0.43, and that's for the 1 class. So let's see how I could create the confusion matrix for this. So this is what I'm doing here is, let me change it to use it for the logistic regression, and that's all I need to change. And we need to transform XC test. So what this line is doing is it's gonna once it predicts the probability of XC test, it's gonna assign it to a 1. So this part is the same as you see over here, right? It's the same thing. So now these, it's saying if it's above whatever value I specify here, assign it to the one class. And what's happening here is it's choosing 0.5 for that. And I can demonstrate that to you by, I will copy it over here. I'm going to do it again. So what was the threshold we looked at? Let's go over it again. I think I forgot. It was 0. It was this one, 43. Okay, this value. So if I use this and do the confusion matrix, so let's see. Yes, it does look different, right? And let us also do the precision recall. It's not showing it, which is fine. We're gonna print them separately. Let's see. Yeah, but you can see the confusion matrix for when we choose this threshold. And I was telling you we can. So this here, I'm gonna use it over here, and I'm just going to comment this out, and just to demonstrate that what we're doing is this actually the 0.5. So you would expect to see the same the confusion matrix if we run this, and yep, it is. And let me. So 72, 5, 15, 28. 72, 5, 15, 28. You see the same thing. That's basically, it's going with the 50% threshold. If we change it, the confusion matrix changes. So this is just to demonstrate again, illustrate what's happening here. So it's basically, this confusion matrix is at this probability threshold. So that's it for understanding ROC curves, and as just with a little change, precision recall curves. Since again we just went over it, the only difference here is the false positive rate and the true positive rate. We have it on these two axes. The true positive rate, you remember, is the same as recall. If you take this on the vertical and if I put the precision on the horizontal and put precision on the vertical, you get a precision recall curve. And so that's it for better understanding of ROC curves.